So this video is going to be a little bit different. I'm going to take a blast from the past, which is a board that is of 96 boards. It's this fellow here that I've used quite a lot in some security research classes and porting and whatever. And I suppose almost for a decade. It's still very relevant, and just one important thing, do not connect 3.3 volt and UART adapters to it, or because it does not respond well to it. So other than that, it's a great device, and I'm only saying it because I just wanted to demonstrate some concepts, and I didn't have the right adapter right now, so this is also why I'll be using some camera. So basically there are a couple of Qualcomm boards that come with all kinds of operating systems. There was a time that Qualcomm did all kinds of Dragonboards, and then it would give you Android when you boot with it. So the boards themselves, this is the 410, and the 820 is not very different. It looks like this, okay? If you want it, you have in the back, you have jumpers that will get you to EDL mode, which is something that I want to demonstrate. It's super relevant also for the robotic stuff. And basically, if you want to get UART, then you would have a ground on. You have the pins here. You get ground on the first pin, which would be this one, and then on the 11th pin, I think it's I think it's TX, and then on the 13th it's RX, and if it's 1.8 you have UART, which will not have in this particular video. I had so many of these, I just gave it with kids on the training that I do. So right now, I just found the board when I was looking for something else, 9 or 10 of them. Qualcomm shipped me on the first shipment when I was doing training for Qualcomm engineers in 2014, 15, I don't even remember when. So maybe 16 this shipment was. So I had a very good run with Qualcomm related products, so thank you Qualcomm. And I just want to show a couple of things that are very relevant also to modern SOMs, because Qualcomm is notoriously hard to work with if you do not have direct connections, and the tools in Linux are challenging. Then there is an advantage that things work the way they are for ages. So if you feel very comfortable around the ecosystem, then you can do very nice things. It's consistent across Android, Linux, robotics, whatever. For someone who is new to it or just works with another SOM vendor that uses Qualcomm, it's a nightmare. But for someone who feels comfortable with it, then it's good. Okay. And since most, if not all, of the high-end mobile devices have Qualcomm chipsets, I'm of course talking about the Android one, then it's not so bad to be friends with Qualcomm. So let me just take a quick pause, and I will connect this board to it's another Android board. It is a projector, but I'm just going to do it. And let's see, and I'll share some nice concepts. So what I'm going to do is connect HDMI. I'm going to connect USB for keyboard. By the way, this board has Wi-Fi and Bluetooth, but you can add all kinds of adapters, either with some mezzanines or expansions, or board, or USB. And I'll connect the power. That's a nice t-shirt also from here. Okay, we have this relative. So I connect it, and it should power up automatically. That's how it should go. Okay. So another thing that would be nice to add would be a USB cable that would go over this connector here. Here we can see that we have a green light now. So green is good. when you do Linux, you'll have like by default the heartbeat usually. In Android it would be green, and I think I should. Alright, so this is like the screen. We have like a good animation, Qualcomm, yada yada yada, and this is the mouse that I connected via USB. Okay, you can see it. Sorry that the image is moving. It is what it is. And yeah, and we have like this Android, and it comes like with very old version. Okay, I'm telling you, it's one of the 5 versions. There is no real need to do that. But trust me, you have like Bluetooth, you have Wi-Fi here. It's pretty nice. Okay, so you can do that. So the thing is that once you do that, sorry for the mess. Once you do that, then you can work, of course, with the ADB tools, with fastboot tools. But what happens if you want to go ahead and use this device for something else, like for Linux? Then you need to start knowing like the Qualcomm ecosystem and the Qualcomm tools. And there are quite a lot of things that you need to do. I'll try to make it like very short. And what I'm going to demonstrate here is using Yocto Project. And later I will integrate with PSCG DevOps on it. I don't know if I will have time to do it like right now. Maybe I'll do it in the future, and maybe I won't. We'll see. And as someone very famous said. However, what I do want to show is how I'm going to do Linux. So I can go ahead and show all kinds of failures, but I will just warn you from them. And the warning goes like this: the Android partition table in all of Qualcomm products and the Linux partition table will not necessarily be the same. The boot speed will not be the same necessarily. And when you want to build like Yocto, either from the reference platform of Linaro or just use MetaQCon and do that, you need to flash another GPT table. Or you can adjust like the image and make it like more Androidish, but that was not like the recommended way to do that. So the idea is that you either do it like manually, or you go ahead and say, okay, what happens if I want to do some recovery thing like that? So there is something that is called the flat build. Flat build, and those of you who try to recover some phone maybe know a tool called QFIL, or all kind of other Qualcomm tools. QFIL would work only on Windows, if I'm not wrong. And the idea is to put it into what's called EDL or QDL, emergency download mode, the Qualcomm Dragonboard. In this particular board, you do it by taking the jumper and setting it like there is a jumper, and the part is not amazing. Let's see what we can see here. So we have these fellows. So you don't know what the part is not amazing, but it doesn't matter. So I need to set like the rightmost one, that is numbered 1 here, to on, and then when I boot the device, it will boot to here. Another nice trick: if I press the minus device here, the minus button here, and then I go like to fastboot mode when I reboot. So what I'm going to do now is I will not go through like the things that don't work. I will just show immediately what does work, and I will show like the setup for getting there. Like when I do training, in this particular fashion, I just give the tools that work to not waste a lot of time. So let me show you that. So to be a little bit more free, I'll do like the last thing here that's gonna act like this cable into the USB entry on my device, and then I'll stop like with the camera because it's not very comfortable for me the way I do it. We can see here that it like recognizes. It decided to auto-rotate. Probably I wrote some application which recognizes the USB device. And let's go ahead and just do like the screen share. Okay, so let's see. Now it should be working and showing this, and if I do like ADB devices and I have this fellow, okay, and I do that, oops, and we can see how ancient it is, like 4.9 dot who knows what. Wow, it was built in 2015, so it's pretty old, not very impressive. And just double checking that like I see the video here. Yeah, I think it's noticeable, but what is going on here? Like, why don't I see the entire? I think I do see the entire screen. I think it's fine. Okay. So if I have this, I can also reboot like to ADB mode. So that's what I'll do now. I'll do like ADB reboot bootloader. I did add to a UDEV rule, and the Android mechanism show you how to do it well enough to add it to deplugue that. So I'll not do it here, but just so you know, this is like the device vendor and so on and so forth. Okay, so these are the rules that you need to add if you want to. It says Qualcomm, etc. And I'll do ADB reboot bootloader, and then I'll see if I see something in fastboot. And I do see it, so I can now go ahead, take an image, okay, and in this example I put them under TMP. I just put an image there, and that I built like with Yocto Project, and I can boot like I can boot with fastboot like a boot image and a root fast image. I took the output of the Yocto Project, which was zipped. I unzipped it, okay. And then this is what I put as the root FS partition after I put a Linux recovery over there. And for the other thing, there is like the boot image itself. That would be this one, I think. Definitely not with the TPs. No, it will be this one. So APQ is the application processor, like of Qualcomm. There is like an image like for the SD card, and there is the image for like the MC. Okay, so this is another option. If I reboot a device, it's very likely in a lot of Qualcomm devices. Actually, I don't know on this one. In a lot of Qualcomm devices, you have the option. By the way, this is like how I built it, like with the Yocto. You have the option to. Many tabs. You have the option to reboot directly to EDL. Let's very quickly check if this one has it. On recent devices, we're in 2025. This is like from 10 years ago. We have it. So I'll quickly check if we have it here as well. Let's do fastboot. Reboot. I don't think we can reboot directly to EDL. Yeah. So we'll do reboot and we'll wait for ADB, and we will try to reboot to EDL. I doubt it is possible. Assuming it's not, then we're going to go to the next step and like set the jumper, and then it will be there. Okay. What I did forget to show. So now I see like over my screen start to see like the HDMI. We see that it's identified like this. By the way, when we handle with all kind of like EDL and recovery mode, it's recommended to disable modem manager system control, okay? But now let's go ahead and try to do reboot to EDL, okay? So look what's going on. It recognizes the QHUSB bulb, okay? We see that it's in QDL mode, product ID 9008 belongs to this. And now I'll show you what I wanted to show if I want to go ahead and like change like the partition. This is definitely has nothing to do with it. So let's see where I work. Okay. So okay, so I'll do I think I need to be security for QDL, but I'm not sure. I did it from another one. I just don't want to expose something that I don't want to expose. Yeah, you know what, I'll just do it a little bit later. I think no, this is for manually preparing the tools. Yeah, so it was under download something, Dragonboard for bootloader EMC Linux, okay? And the idea is that I'm going to do export path equals $path, and then I think I said 10 rootfs QDL, I think so. Yeah, we're good. So the idea is that we're going to do QDL, and then the programmer, which is this fellow here, and then we provide a raw program and a patch. Now both of them define which of these images over here will be flashed. So they can be the bootloader, they can be trust zone image, they can be the GPT partition, they can be actually like the entire the entire rootfs or whatever. They can be entire Android images. And when you have like a production image and you use like tools like QFIL, then you also usually just put everything, not only the recovery that I'm doing now, but now what I'm doing is enabling things so that I can use fastboot in order to flash those. So I'm going to do this and check it out. It says Qualcomm blah 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 blah, and disconnected. Set bootable drive, partition 0 is now bootable. Good. And we can see again that the thing changed here, and check it out. It says Google, it means it's fastboot. And we can see the ID vendor and this guy. So we flashed it and then it like rebooted to fastboot. Let us prove it. Yeah, so it's exactly what it did. So just reminder, I rebooted it to EDL from ADB, which is nice. This way I don't need like to handle jumpers. Otherwise I need to start handling jumpers. So long story short, and by the way, flashing the rootfs will take time, so it will be a long story. If I now want to reboot the device, like nothing really will happen. Now I don't have UART here, unfortunately, so I can't show you like like the output or what's going on or what happens like if I have like a boot image but I don't have rootfs and so on. But I'll just flash the things and then we'll move on with that. So that's how I called it. I'll do fastboot flash boot this guy that I built myself. This takes like nothing, okay? And the other thing I will do would be fastboot flash rootfs. I think that's the name of the partition, and then what I unzipped. Now this will take time. It will take a lot of time. And the reason why I did things like with hey, let's flash like the recovery and let's do it like the right way is because otherwise you can flash almost everything and then it'll tell you, hey, you don't have a partition table on the device, or you don't have this, or you don't have that. And you can wait a lot of time, and you will wait a lot of time. So I will just let it happen. Just for fun, let's see what is the size of it, okay? I think it's like 600 megabytes. I built a full command line for this device, and yes, whoa, it's not 600. It was compressed. It was 600 megabytes. Actually, I have no idea why it's like so big, but yeah, whatever. I can check it like on my build. which I think I did here, but I'm not 100% sure. Yeah, I did it here. So that's actually good because I didn't do almost anything here, okay? I mean, I just used the ARM V8 like a machine over there. Let's see what layer I included. I included Meta QCOM just as it is. We can look at this. I just took it from here, okay? I used the Scarscap branch. I could use master also, that's fine. And like in local conf, that's what I did. I selected like the machine to be QCOM ARM V8A, and I did bit bake to like full command line, and that's it. That's like what I built here, okay? So I deliberately didn't change almost anything. But you know that here you also have like, you know, like the Qualcomm firmware and everything checks out. And there's like this generic thing here. Now there's also like the Qualcomm extra layer that give you like all kind of things. Not getting into it. Like the goal here is just to prove that we're able to do things. And I mean, you know, I'm talking and I'm saying, and this is still like flashing. So it does take time. So like while at it, yeah, I have like fastboot, and it's an old device, but it's an old device that the mechanism of works, like working like with QDL and these things, it's still relevant. It's still very relevant. Now, the image is huge, so it will take a lot of time. So of course one can shoot like optimize it to make it better, but this was like the quick and dirty. Quick for building more or less, although it's of course not so quick, and less quick for writing. So I'm going to like pause, and I will let it. You know what? I will not do it. I'll show a couple of more things here, like just for fun. So if I went to the Dragonboard C bootloader. Okay. Then, if we look, what can be interesting? By the way, like these tools, if you use Qualcomm robotics and things, many times you get like a flat build, and you will not be able to use it for Linux easily. Like so, the nice thing about the 96 board is that you know it just works and it's fine. It's like really nice. So you don't need like any applications, you don't need like the Qualcomm tools which can be challenging to set up. It's always one driver, more than four. I don't want to criticize anything. I was going to even talk about it in Embedded Open Source Summit Europe 2025, but I wasn't able to do so. So this is maybe part of what I would talk about. Yeah, so it's still like writing, it takes time. So when all is done, like you should say, see like okay again, okay. So what did I want to show? Yeah, so for example, like the row program, this actually tells you what to write where, okay. Now one of the things that you write would actually be like the partition table. That's also part of it, okay. So we have several things here. Here we have like the A boot, like the Android boot. Here we have like the GPT partition and like the backup of it. And that's what we have. And patch also has like additional things that are written like over there. Okay? I mean, you don't necessarily need to fill all entries. Okay. So it's writing and still happy. I mean, these are like from the message, okay? So these have been some of the tools that have been needed here. Now QDL, as for QDL itself, let's delete it. QDL I put in another place. But if you want to handle like all kind of Qualcomm tools, then it's very, very, very likely that you will need to build, even though you have like the Qualcomm Package Manager 3, PCAT, and all those like graphical tools that are also command line tools. They are not very friendly, and many times like the auto installation will fail on millions of things, which is quite annoying. It can fail like this is what's called the QUD, the Qualcomm USB drivers, and I don't think I ever managed to not like build it from the command line for it to work. So yeah, so basically this is like we're still waiting here, okay, which is not so sympathetic. And I could pause. It just takes a lot of time. So imagine what if it fails, like how frustrating it can be. Okay. So, by the way, this is the current. I mean, I just looked at it today. RPB is the recommended reference platform builder. I think that's like the abbreviation. It wouldn't work out of the box for like the modern distros. You need to start adjusting some of the things here, at least for like this board. So I just built it like with a good old Yocto, like took Meta Qualcomm. This is also like what Qualcomm say, do not use RPB, just use Meta Qualcomm, and that's like what I've done. So I'm still waiting. By the way, in this Yocto image, and when you build like this, you don't get like fastboot and things like that, which is not the case for when you build with Qualcomm Linux, which is subject for other talks. This particular validation board, yes, it came from Arrow, but it can like directly from Qualcomm. So I mean, I don't mind doing this. If other Qualcomm SOM vendors, I've been working on one of them like a couple of months this year, but they did not want to sponsor a conference, so I don't feel like giving them any credit. So I could show some things on their device, just prefer not to. It's also not so important, the idea is that the concepts are like the same. It's so bad. They have cheap SOMs, relatively cheap SOMs, nice evaluation boards, and they do an okay job. So anyway, this is oops, something I had in mind. Please don't even know if fastboot is still, yeah, it's still flashing it. So I'm just going to pause it. I just want things to be authentic, and of course, like you can wait and wait and wait and wait. It's about to be done, though. I mean, I know it's about to be done. So yeah, I mean, I don't want to cover too many subjects or too many things. So let's wait. The moment I'll pause it, then it will already work. Yeah, that's my fault. Alright, so look how much time it took it, like 10 minutes. I mean, that's quite a lot. It's not so nice. And now we need to fastboot, reboot, and I don't have like a 1.8 volt TTL USB like an FPGA adapter, so I'm not going to do that like now and show it the serial, but we do need to do a reboot. So let's go ahead and get the camera working again. Yeah, it's not like the ideal way, but at least it shows that I'm saying the truth, right? So I'm going to now go ahead and I did the fastboot reboot, and there are two things I want to see. Okay, see, this is like the heartbeat, and you'll see pam 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 pam. We see Yocto Project, and I built a command line one. So yeah, the resolution is not amazing, and the USB connector. I think so. Actually, when I did it before, yeah. So this is it. And that's nice, I think. Okay. So we have this. We have like the command line, and it's pretty nice.